Welcome to the first session on role of GIS in supply chain management. I'll be talking about the role of geospatial technology in supply chain management, where we will be addressing most of the areas which directly or indirectly links to GIS as well as geospatial technology to supply chain. In fact, as mentioned by our director as well as the our chief guest, that this technology has got tremendous potential, and in fact, many people are practicing this technology in supply chain. So, in fact, if you see all entire lecture, I'll be talking about the concept of supply chain management, the basics of geospatial technology, how GIS and its characteristics are linked, and then the different stages of supply chain management, and then we will touch upon few components of GIS wherein supply chain management can be used. The database creation, geospatial analysis, dynamic visualization, dissemination, and analytics. Another part is the use case. I will mention few use cases which I think some of you might be aware of. And the intention of telling about those use cases will give you an idea that how this technology is linking directly to supply chain. There are way forwards, as mentioned by our past delegates, as well as our chief guest also, that what is the role of the new technology, especially artificial intelligence, machine learning, deep learning, as well as big data, because all these technologies can really provide important inputs which can ultimately make the business outputs more appreciable and reliable. Well, coming to the supply chain management, this particular concept, it has been explored, and in fact it has been told by many agencies that it primarily discuss about the management of the flow of goods and services, which involves the movement and storage of raw materials, work in progress, inventory, and then finished goods, as well as end-to-end order fulfillment. So we are moving from starting point of origin to point of consumption. So you can see that there are different stages of supply chain, and this supply chain may not be, it may not cater to all the supply chain processes which are being experienced by many people. There might be few changes in this supply chain, but overall, the supply chain process flow is almost same. But what is the need of this supply chain? The basic need of supply chain is we have to provide the right product in right time at right place. So in that case, the consumer, because ultimately you have to make your customer or consumer, he should be happy with your services. Only then you can have the better business perspectives. Now, if you talk about geospatial technology as a whole, as mentioned, that it basically talks about the geospatial data, because when we talk about geospatial data, we are talking about the location. The location wherein you can either gather it, you can store it, you can process it, and you can deliver the geographic information. So if you see the geospatial technology, there are three tiers which govern the geospatial technology, along with some other value added, or I would say an add-on technology which provides impetus to all these three components. The first tier of geospatial technology is remote sensing, wherein we talk about the satellite data. We have the Earth observation system in place in India as well as across the world, which can provide a synoptic information in the form of satellite images. And then you have also geophysical products which can ultimately provide you more derived information which can directly be used by a stakeholder. Then comes GIS. GIS, Geographical Information System, is I would say is more of an umbrella where you can capture all the spatial information, the locational information, which can be integrated into GIS, and ultimately it provides a mechanism by which you can provide some value added information by overlaying all those individual maps together. Then we come to GNSS, Global Navigation Satellite System. This is, I think, many of you are much more aware of this technology, especially children who are making use of these mobile phones for many purposes. They might be using for navigation. They might be using for ordering their food, they might be using for traveling, they might be using for any other application where location information is important. So I think to maximum extent the GNSS application along with GIS is providing a value added information within the gamut of supply chain management. Field sensor is also an area where you can make use of IoTs as well as so many other devices, smart devices, which can be linked to this particular domain. The last, information and communication technology, is a mechanism by which you can transmit your data, you can communicate with the data on different platforms, whether you're talking about mobile, whether you're talking about a web platform, any platform, this ICT technology can really help you in achieving those objectives. So overall, if you see the geospatial technology, as I told you, GIS has much more upper hand as compared to other because it directly relates to supply chain management. Why? Because of its capabilities to integrate different type of data sets which can be integrated together and ultimately can provide you some hidden information which you might be looking for. The GNSS, as I told you, that it quite important with respect to positioning of a particular person, of a particular utility, or any other things which might be mobile in nature, so that those things can be directly captured and you are able to navigate those information and ultimately it comes to the database. You have indoor positioning. That is also an area where you can make use of technology like RFID or even a Wi-Fi. Those things can be quite useful, especially in supply chain management. Earth observation, again I'm coming to remote sensing, where you might be having different platforms, you might be having already existing data sets, historical data sets, which can capture some of the permanent attributes which are available or which can be seen by a satellite data. So you have satellite remote sensing, you have aerial mapping, and then you have UAV or drones. The last, scanning part, there is another technique by which you can make use of, like you have active sensors like LiDAR, laser scanning, or radar. That can also be an important information if you think it can be used for supply chain management. Coming to the concept of geographical information system, as I told you that it is a total system which can provide you four sets of capabilities to handle a georeferenced data. So the system, the GIS system, has a capability to input the data, means any data where you have location, it can directly be captured by geographical information system. And once the data comes, it can be managed, it can be stored, it can be manipulated, and then it can be retrieved at any point of time. The third part is the manipulation and analysis. that makes GIS much more powerful as compared to other components. Like manipulation analysis means once you have all these GIS layers available, you can directly integrate them. Means you might be having some layer of road network, some layer of facility management, some layer of distribution centers. All those data sets can be combined together, and ultimately it can provide you the desired information which you are looking for. And it is not possible for you to really create the hard copy maps or the paper maps, which ultimately can only help you to overlay 2 to 3 maps together. But here you have a capability to have integrate n number of maps together, and ultimately it can provide you the information. The last part is the output. In fact, output, I would say, I will not call it as an output, rather I would call it a dynamic visualization, or I would say the visualization, because it was mentioned in the last during inaugural that you have spreadsheets, you have database, but once you transform them in the form of maps, it conveys million words, it conveys lot of information, and ultimately that map can help you to come up with a real solution, because it will give you the actual information on the ground. And once you visualize them in the form of map, it can really help you to give all that information. The second part, the key properties of GIS is where, what, how, and when. As mentioned by the previous speaker, that where means where is that object, where is that facility, where is that raw material, where is that finished goods. Everything lies with where. So you really have to capture that geospatial data which has got latitude and longitude, and that too, this latitude longitude has to be more precise. If you have more precise information, you can really come up with good solution, because the uncertainty or the accuracy of the data lies with your output. So whatever accurate data you will provide to the system, the better output you can visualize once you do the analysis. Then you also talk about what means where means that location, what is that object, how it is related to other object, and when it is going to change. If you are able to address all these W's and H, your GIS system can really help you to achieve this. So basically, when you talk about GIS, there are two types of information which are carried in GIS. One is the spatial data, another one is the non-spatial data. Spatial data basically talks about the location, the features orientation, whether it's point, line, or polygon. Point means point will have latitude, longitude. Polygon means it can have an area with an extent. The line will also have an extent. That is nothing but the spatial data. And the non-spatial data is what is that line, what is that polygon, what is that point. That gives the attributes to that information, and that attributes could be infinite. You can attach n number of attributes as per your requirement. The information, the any GIS system, whether it is commercial or off the shelf, the open source, it will have tools to create those data, to model them, and ultimately provide you the analysis as well as output. So basically, GIS data, why it is strong? Because at the back end, it uses database management system. Because if you have a database management system, you can inherit all the properties of database which will go into GIS. Means you can store the data, n amount of data can be stored, it can be managed, you can fire any type of query, everything can be done once at the back end you have the DBMS. So GIS has a DBMS at the back end so that it can provide you a lot of information. The last part is you can create your own decision support system. Now here, decision support system, what I mean to say is very precise, because whenever you talk about supply chain management, you ultimately going for decision support, and for every use cases you can have your own decision support which can be built by making use of geospatial technology or by making use of geographical information system. Now here I would like to mention, I'm not going into the details of GIS, but here I would like to mention you that whatever data you are trying to create, the GIS supports two types of data. One is the raster data, another one is the vector data. Raster data basically talks about pixels, grids of rows and columns, which is equally spaced and properly the mosaic. But when you talk about vector, vector could be point, line, polygon, and any information in the geographical phenomena or in the real world you want to store, it has to be stored either in raster or in vector. So these are the two important formats which are being supported by all the GIS software, whether it is commercial or open source. Now, another part I was mentioning is GNSS. As I think many of you are aware that at present most of the mobile phones are equipped with GPS, which is a constellation of 24 satellites supported by United States. And in fact, there are so many other navigation systems which are present available. In fact, for India, we have our own Indian Regional Navigation Satellite System, which is also known as NAVIC. In fact, it caters to around 1500 kilometers beyond geopolitical boundaries. And in fact, it is all weather and it provides all the location information which is being accessed. And in fact, we have also an SBAS system which is called Gagan. In fact, there is a possibility that there might be some inaccuracy because of the GPS location. So basically, here we can improve our GPS information by making use of Gagan SBAS system, satellite augmented system. So the basic objective of GNSS is to provide important positioning as well as the navigation of the entire information. So any information which might be mobile or static, it can directly be captured through these satellites, and ultimately you can get that where information, means the location information. Similarly, there are so many other applications which floats into GPS GIS integrated system, like automobiles. You might be aware, I think each one of you are experiencing the Google Maps as well as the navigation. Map My India is also providing the routing mechanism. So ultimately, all these navigations are governed by both GIS as well as GPS. There are so many location-based services which are being provided by the service provider, and most of the industry, or I would say consumer, is getting benefited from this. So there are so many online food delivery, tracking rental cars, and then you have airline safety, then you have agriculture, tracking livestock, yield monitoring, ship routing and management, even the transportation via sea routes, oil tankers, cargo monitoring, law enforcement, and in whatnot. I think there are n number of applications which make use of GPS GIS integrated. You may not be aware that many information which is coming directly to you is a combination of GPS GIS, and you might be not aware that how GPS GIS integrated system is providing you that information. So if you have these those two technologies together, they can really provide you important information. Now we come back to the basic stages of supply chain management. You talk about raw material. There are many applications, from agriculture, farm to fork, cow to consumer. Then you might be having like geotagging of cattle. You can do it with geospatial technology, pump irrigation services, potential fishing zones, satellite-based crop yield estimation, forest cover mapping, UAV-based pest management. There are so many areas where this particular technology is being practiced. Then construction and mining, you have high resolution data. You can progress how different projects are being monitored by making use of this technology. Then you can also make use of AI and high resolution image based truck monitoring and extraction estimation. So even in fact, there are so many natural resources or disaster application where this technology is being directly used. In fact, there are so many platforms where this technology directly provides benefit. In fact, there was in the recent Uttarakhand disaster, there were many inputs which was taken from the satellite data, because that is the first input which can come on your desk, and that input can help you to decide what type of remedial measures can be thought of. The second stage is the processing units. You can really make use of these technologies where you should have those processing units. What should be the exact location where I can I can mobilize my resources. All those things can be handled by making use of GIS or geospatial technology. You can even talk about the location-based information like labor issues, geopolitical unrest, medical emergency, natural disasters. All those things can be directly catered by making use of geospatial technology. Finishing products is also an important area. You can have direct, precise information on time to the consumer. You can also make use of IoT and sensor-based information on location and status of vehicle. Like you can monitor that how the entire product from the processing unit, it is this product. It is being carried over truck, or it could be any. You can monitor those things, and also you can link the driver related, like his health parameters can directly be linked to your dashboard. So those type of monitoring mechanism, the biggest example is 108. I think they are making use of this technology in total, so that they can monitor where actual requirement is, where the patient has to go, which is the optimal route, where by which they can save time. Then we have possible traffic blockages. If you have the good information related to congestion, you can directly reroute those different routes, so that the information can be reached, or the product can be reached in a least stipulated time. Then you have multi-depot and multi-delivery location transit network solution. This is really important. You can really think of that what could be the optimal ways. Distribution centers and customers. This is always a challenge for us. In fact, the distribution centers and customers, the mapping and remodeling of large retail outlets for better customer engagement, identification of best outreach location, location-based advertising, and remapping of change in customer requirement to entire supply chain for minimizing any adverse effects. So these are the basically good information which can provide you better distribution centers. So now coming to the different step-by-step processes which will be elaborated by my colleagues. Here I would like to mention that the supply chain asset digitization is one of the most important tasks, because whenever you are coming up with a new industry, you should have a proper repository of your asset, and for that you have to make use of geospatial technology or GIS. The most important part of any organization or any project is the database creation. So you really have to create those data sets, which is considered to be a most expensive part. So you have to spend some time on how to create those assets. Whether you can create those assets by making use of the existing satellite images. There are a lot of plethora of satellite images which are available on open source platforms, like Google Earth Engine, or even there are so many other gateways by which you can directly access the satellite data. It may not match your specific requirement in the sense that if you are looking for a particular date, you may not get it, but at least historical data is already there in the portals by which you can directly. The biggest example is Bhuvan portal, where for the entire country, lot of satellite data in the archive mode is available. Similarly, the field data corresponds to an important attribute for the asset management. So you have to create the field data by making use of mobile applications. Like there are so many mobile apps, or I would say applications developed in open source, like Open Data Kit, ODK, which is called ODK, where you can directly make use of that application. You can design your own forms and ultimately create the baseline information which is required for your supply chain. You can even make use of street addresses, reverse geocoding, all those things you can do it. Paper maps can be digitized in the form of digital maps, land surveys, websites, mobile, crowdsourcing. So many platforms are available by which you can create your asset data, because the asset data is considered to be the primary data, or I would say a baseline data. And if that data is available with you, it will be easy for you to manage all your resources, and ultimately it can save a lot of money for you if you are coming up with a new startup. Similarly, you have types of data: primary, secondary, spatial, non-spatial data. All these data sets can directly be created by making use of this technology as a whole. Now, once you have these data sets, you look for better management in the sense how these your products can be transported from one point to another, whether it is moving from one warehouse to another or from warehouse to the consumer. So all these different requirements can be catered by making use of one of the algorithms given in GIS, that is called networking analysis, where basically our main objective is to provide the best possible route on the basis of the different impedances or resistance along different cross sections. So you might be you can see that there are few figures which I am trying to show that for every road segment you can provide the impedance. The impedance could be based on traffic, the impedance could be based on speed, the impedance even could be based on time, so many different factors. So the database creation is very important, and once you give these impedances, the algorithm will help you to provide the optimum route. So here I am just showing you 4 different locations, but think about the overall supply chain which is from one point to another, moving all across the country. It's really difficult to manage. So you have to make use of this technology. Once you have good asset data available in the form of a database, you are able to use this algorithm to give you optimized route, as well as there is also concept of service area. Means once you have a distributor or I would say one distributed warehouse is there, you can directly make out that it can cater to all these areas. So these type of already inbuilt applications are available in GIS, which can help you to manage your entire transport and logistics. So I think you can explore this algorithm, and there will be a detailed lecture that how these different type of algorithms can ultimately optimize your resources, and ultimately these optimization can lead to better results and ultimately can satisfy your consumers. Then you have spatial analysis. Once you have all these data sets, networking was one of the concept. Another one was a spatial analysis. As I told you that there are 2 types of the way you can store your GIS data. One is in the form of raster, another in the form of vector. And all these raster, vector have got different type of analysis techniques. So means it can allow you to store the data in the form of raster, and once you have the raster data, you can apply any type of arithmetic operations, any type of modeling can be done on those data sets. Similarly, for the vector data, you can apply any type of overlay operation. 100 layers or 10 layer, 20 layers can be overlaid together to come up with a single polygon. Like you might be wondering that if I want to establish a new distribution center, how I can do it? You can easily do it if you have all the GIS layers available. And once the GIS layers are available, you can fire a site suitability analysis where you can use different multi-criteria techniques, whether you use analytical hierarchy process or you use weighted summation model. Those models or those techniques, you only have to input the data. Automatically, it can show you those polygons where your criteria are satisfied. So all these applications ultimately can really help you to narrow down your search with respect to the spatial domain. The advanced visualization and analysis is an important area where mapping and visualization of location is important, where you look for real-time tracking and planning, you look for demand and supply, forecasting, you look for distribution network and optimization, and you look for risk management and mitigation. So all these different applications can directly be catered if you have the data sets with you, if you have the ultimately the analysis techniques which are available. So once you do the analysis, there comes the analytics which can provide you useful information which you are looking for. Another area is the visualization and dissemination. In fact, here what I am trying to show you, in fact, there will be a detailed lecture on the visualization and dissemination part. Here, the basic objective of this particular technology is, once you have the data, once you have the analysis, you look for dynamic visualization. Like you want to pinpoint few areas where how my entire product is behaving. So those type of analysis can directly be done by this adaptive simology based on the current selection or view. You can even do some statistical analysis by which, by understanding that, you can see that how the analysis can be done in a given section, and there you can have some interventions so that it can be further improved. Similarly, there is a concept of link and brush technique where you can have those 2D views for high dimensional data, because here we are talking about n dimensional data. There might be some data coming from various sources, how you can integrate them together. And once you integrate them together, you make use of certain technology like OLAP operation, online analytical processing, where you can understand your data, the multidimensional data, and generate some drill down or roll up operation which can be visualized on a 2D domain. There are few plugins which are available on atlas generation. Once you have these data sets, you can create your own atlases for various applications which can relate to your requirement. And then the dissemination could be form of a real-time visualization, it could be through dashboard, or even you can create those PDFs, day-to-day PDFs can be generated and can be passed on to your different sections. So these type of mechanisms, or I would say the GIS can provide all these things in toto, and you don't have to search for the individual applications. Now here I would like you to mention a few good information on the 3D utility models. Now here I would like to mention that the 3D models are now playing a very important role, especially because here the most important is 3D indoor logistics. So you can see that GIS provide you to create those 3D city models. You can even create like you can see the multi-scale modeling, means the entire area can be modeled by making use of different level of detail, LOD 0, LOD 1, LOD 2, LOD 3. And you can see the last part where you can model the entire indoor with all the utilities. So these type of 3D indoor logistics can be created for all your warehouses, because it is not possible manually to really monitor all your different supply items. So these warehouses can directly be linked, or I would say the individual packets or the individual containers can directly be linked with RFID or Wi-Fi, so that you are able to manage those things on a dashboard. So those type of 3D models for indoor logistics as well as outdoor logistics can be created, and ultimately it can provide you good monitoring system by which you can manage your resources. Because if you are working with different like Amazon, I think Amazon might be really making use of all the different techniques by which it can provide good products to its customer in a least possible time. Now coming back to the case study, here I'm just would like to tell you that dairy development in Dehradun is one of the case study which my colleague will be demonstrating to you tomorrow in all these segments. Here I am only briefly I am telling you that what all requirements are there. Like you can see that village level collection center, then you have bulk milk coolers, daily processing units, all those different components of supply chain are involved. And once you see this, there is a lot of direct or indirect linkage to many other things which may not directly link to the dairy. Like for instance, fodder development. You might be wondering that how fodder development is directly linked to the cattle's where they have to come for grazing, and then you have to provide the best possible fodder so that you can have better quality milk available with you. So how we can work on fodder development, how we can have a good milk chilling facilities, how we can have the best monitoring of our cattle, how they are moving from place to place, and then the transportation. So these are certain problems which can directly be catered by making use of GIS. Fodder development, GIS can allow you, or it can help you to create those areas where you can have better facilities with respect to soil availability, the groundwater, the surface water, all those basic requirements which are required for fodder development. In fact, there are a lot of satellite data sets available. You can even fly UAVs and you can have the real-time assessment of those areas. Then you have milk chilling facility. Where I should have those milk chilling facility, because it's a big infrastructure, I would say big expenditure which is involved in milk chilling facility. So you really have to identify in which area I should have that milk chilling facility. So for that you have to use GIS, which is the best possible place where this particular plant can be created. So it can be linked to many other requirements, criterias by which you can directly apply, and you can have the best possible place where you can have this facility. Then the cattle development, how you can monitor your cattle, how you can make use of GIS, or I would say a mobile application which can ultimately help you to geotag those areas, and also you can monitor them by making use of different technologies. The last is the transportation, how the milk from point 1 to point 2, how the transportation is done, how we can because in this dairy product, time is very important. Everybody wants milk in the early morning, or maybe some of them might look for the evening. So the time is bit less. How you can manage this? So this is always a challenge. So GIS can help you to create those information. So out of the box, I thought that I would like to mention here the role of GIS in COVID-19. You might be aware that these type of dashboards are being created worldwide. It's not only limited to the global area. Even in India, there are portals available, like Bhuvan is one portal which provides the all monitoring of the COVID-19 cases with the state level analytics available. And there are industry like you have Map My India, and then you have industry from ISRO India. Everybody is really working hard to provide that information. So it is because ultimately it is the basic objective of these type of dashboard is it gives you a fair idea that where is the distribution happening. Where means W, what is that location, what is happening. So all those W's and H are being addressed in these type of dashboard. And even if you go to specific country, you can have more drill down operations which can provide you even better insight of this information. The second thing is, I would like to mention that although it was mentioned that oxygen, how we can manage the distribution of oxygen in different states by making use of GIS itself is one of the challenge people can make use. But here I would like to mention the COVID vaccine and other health related supply chain. Earlier, if you don't use GIS, you will have problems of lack of real time visibility, no visibility of storage temperature, short shelf life, drive, non-standard record keeping, mismatch in demand supply, limited infrastructure, lack of transparency. All these problems you will come across. In fact, the same thing is being realized in distribution of oxygen cylinder. But if you see the overall COVID vaccine, it has been done in a systematic way, and you can see that the health centers have been geotagged, the mobile applications have been used for tracking supplies, and then even the proper inventory of different type of medicines are available, which can ultimately provide you better transparency and accountability. So these type of GIS applications, once embedded into the real-time application, it can really provide you best possible solution which can reach to the consumer. So this is another example of the Dehradun utility network planning, where if you can use this GIS, you can have a better distribution. You might be, the demand is more, the supply is less, but if you make use of GIS with proper monitoring system, or I would say better implementation, it can provide you best way of managing your resources. Because if you have limited resources, you really have to make use of the technology so that the optimal utilization can be done at grassroots level. So these are some of the examples of Dehradun utility network planning. Now here there was one success story of the Anand, the Amul company, but here I would like to give you a success story of Dabbawala in Mumbai. In fact, there is no technology used, and I would like to spell out about this particular system based on barefoot men, public trains and simple reusable containers in a city of some 12.5 million people is widely regarded as one of the top performance stations in the world. In fact, the 125-year-old industry using Dabbawalas was recognized at the 6 Sigma level by Forbes in 2002. And in fact, more than 175,000 lunches, as per the given information, 175,000 lunches are moved and delivered each day by an estimated of 5,000 Dabbawalas across Mumbai. What's more impressive is that according to a recent survey, Dabbawalas make less than one mistake in every 6 million delivers. So that is the real efficiency. And I don't want to just tell that, see, there is no technology used. But here I would like to mention is that everybody cannot be like Dabbawalas. They have a good model. So here I would like to mention that if you are sticking to your actual requirements and you are taking the entire work as a whole rather than pinpointing one single lunch or those dabbas, you will fail. So if you make use of these technologies, which I am mentioning, everybody could be like Dabbawalas, where you make use of this technology and you can cater to much more wider area within the country, across the country, or across the globe. So this is a classic example that how they have managed their resources, and that too with limited manpower, with limited resources available. So this is a success story. I think we must follow some good attributes from them so that we can use this on the overall supply chain. So well, I would like to mention you that you might heard that according to the Organization for Economic Cooperation and Development, the pandemic was a major fall in global economic growth. In fact, you will be surprised to know most of the companies based in Asia, Australia, Europe, America and Middle East, there was a big loss because of the pandemic. In fact, the Institute for Supply Chain Management surveyed that 75% companies reported supply chain disruption owing to coronavirus related transportation restrictions and large scale quarantine as well as lockdown. So all these implications, so you have to be ready that how I can overcome all these challenges so that I am able to provide the product to the consumer. Because if you are disconnected with your consumer, you will lose your business. So you have to make sure that if you adapt this technology, it can ultimately provide you good results. So there are challenges in traditional approaches, whether you go for optimized localized storage or you go for centralized warehouse. There is always pros and cons coming up with the different type of approaches, whether you can have an n number of localized stores, or you can have the centralized one single store. But there is always problems associated with both the techniques. So basically, if you want to overcome all your traditional challenges, you can make use of not only GIS but also AI, ML, and DL, as well as big data. In fact, the AI, ML, DL can really help you to process all those information which are available in bulk, and ultimately the algorithms can give you some hidden information which you might be looking for. So ultimately, if you adapt all these technologies along with big data, you can have some good information available. So I would like here to mention you that most of the supply chain management are driven by deterministic models. Deterministic models means they are already predefined, means from point A to point B, point B to point C. So it is only a simple predefined mechanism is there, which are more of deterministic in nature. So the losses which you might have seen in the previous slide, there are few companies which are only following the deterministic model. They might have been failed. But if you use a non-deterministic model approach, that is more a probabilistic approach, where you have the historical information available with you, you have mathematical models together, so that you can have the prediction. So with this, all these scenarios can be clubbed together, and you can use this machine learning to ultimately have a projected, or I would say better predictions, and wherein you can work on those lines. So rather than sticking to the conventional model, rather than sticking to the deterministic approach, you better can opt for the probabilistic information. So this is the application of big data in supply chain operations, where you can have a delivery mechanism which can be monitored throughout, and ultimately any type of breakdowns can be avoided by making use of this application. Then you have inventory planning, automated demand forecast data to eliminate understocking as well as overstocking. Then distribution on the basis of material flow. Then demand forecasting, and this can also come if you have a better historical data. Lot of data is flown in the form of big data, and if you can capture those data sets, you can really come up with some better forecasting results. Warehousing, the analytics of real-time big data within warehouse enterprises, resource planning system, and recognized inventory levels. And the last part is the scheduling, how you schedule your data, because scheduling can really make all the applications in a better way, and the monitoring system can also be developed. Once this entire process can be scheduled, then the entire automation can be done, then you will have less problem, and you can have better outputs which you are looking for. So basically, you have to follow a three-step process. You have to have the prediction, the understand from the historical data what is the supply chain structure. Then you have to ultimately shape the demand by establishing transparency, and ultimately you have to build a platform where you make use of AI techniques, where you make use of all the algorithms which are available with you, and come up with the best possible solution. So these are some of the examples of agricultural supply, where you talk about the smart mechanism, smart agriculture, where you can use in your in your plantation, or I would say in your agricultural fields. You can have the IoTs, you can have drones, you can have the sensors. Smart sensors can be installed which can monitor the health of the agricultural crop, and that crop can directly, that information directly comes into the database, and you have a better mechanism of how much yield I can generate, how much accountability can be developed, so that you can have better way of assessing your overall requirement. So this is a classic example of identifying the plantation, then linking all these plantation with the satellite data, because a lot of historical spatial data are available and they are being correlated with the business data. So find key drivers and build yield production, and ultimately once all these data sets are available with you, you run a model, and then you can have a better improved business decisions which can help you in managing the entire supply chain. So ultimately, if you have use of all these AI, ML, DL, as well as big data, you can have better mechanism of safety. You can have a better decision making. The transparency will be there. The online delivery can be made more faster, and ultimately the warehouse efficiency, inventory demand, as well as accurate inventory management can be thought of. So ultimately the overall the entire area, or I would say the entire stages of all the supply chain, can be better managed by making use of this AIMLDL. So these are some free and open source software for GIS which can ultimately provide you to create those supply chain asset data. The asset digitization can be done, the networking analysis can be done, the visualization as well as analysis can be done, and ultimately you can even disseminate the data in the form of services. So all the plethora of softwares, open source softwares are available. You can directly access those open source software and you can develop these applications. Even there are some very specific supply chain management softwares are available. Some of them are, I think all of them are open source, but few of them are free, which can allow you to customize your information. Inventory management can be done, order management can be done, warehouse management can be done, as well as shipping and tracking can be done. So all these softwares in fact can really help you to develop the entire chain of supply chain, which can have a better process flow among different components. So in the end, I would like to mention over here is the availability of geospatial data in real time is one of the most key performance indicator in business intelligence. So I think if you have all the data available in the form of maps, in the form of locational information, it will really help you to monitor the real time. The second thing is the geospatial technology from top to bottom, whether you talk about remote sensing, whether you talk about GIS, whether you talk about GNSS, whether you talk about ICT, or whether you talk about field-based systems, they can really provide you better management and optimization of resources. The use of GIS provide better opportunities for startup. In fact, here I would like to mention that if the startups, they may not have good amount of the good finances available with them, if they can make use of these technologies to really manage their resources, it will be good for them. So you make use of this free open source software and try to create the data sets which can help you to manage the resources properly. The integration of recent geospatial tools like 3D indoor mapping for managing big warehouses, virtual reality, augmented reality, real-time tracking, and dynamic visualization on dashboard may avoid any type of disruption in supply chain process. The adaptation of non-deterministic model means a probabilistic model using AI, ML, DL, as well as IoT and big data is need of hour and would lead to smart supply chain management. We really have to adapt these technologies so that the efficiency or the effectiveness can be increased to many folds. There is a need to create awareness about GIS in supply chain management through capacity building program, the way we are doing it now, and also various stakeholders involved in supply chain process. So this is the overall thoughts which I think I can share with you, and in fact all the processes which I have mentioned to you about this will be covered in detail so that you can have a better picture of implementation as well as the overall process flow. So with this I end my talk. So thank you very much.